So far we have looked at the greatest common factor, the difference of two squares, trinomials with a coefficient of 1, special trinomials called perfect square trinomials, and now we're going to look at the general trinomials. They're in the form of ax squared plus bx plus c. Our leading coefficient is no longer 1. There are several different methods to do this factoring. I am going to teach the guess and check method. If you know of other methods that you prefer, that's fine. So the guess and check method says that you need to list the factors of A, which is that number, and list the factors of C. Then we're going to pick two factors of A and pick two factors of C, put them in there, see if it works. That's why it's called guess and check. If you get that middle term, it works. If not, we try again. My job is to try to help you understand to make some better choices. Sometimes to pick the two factors, we have some hints on which ones to pick. So let's just see. On number 1, factor completely. It's a little bit easier when the first term and the last term are prime numbers. Remember what those are? Primes can only be divided by themselves and 1. And so when we list the factors of A, the only factors we have are 3 and 1. And we list the factors of C, it's only 7 and 1. So when we put them in the parentheses, I know I have to have 3x times 1x. That's my only choice to get 3x squared. And my only choice to get 7 is 7 and 1. But this time it matters where I put them because I need that positive 10. So let's say I put the 7 here and the 1 there. I have to multiply to check if the middle term results. So let's see, if I multiply that, I get 1x. If I multiply that, I get 21x. I'm doing the FOIL method to check. I'm doing the OI, outer and inner, because those add up to the middle term. Well, that gets me 22x. That does not get me 10. So I know that that is not the right way to do it. So I'm going to erase and try again. So I'm going to put the 7 here and the 1 there. That's 7x, that's 3x, and if they're both positive, I get 10x, which is the middle term. I know a positive 7 times a positive 1 is a positive 7. If these are all positive, I get a positive 10, and that is my final answer. Not that hard. Well, let's look at number 2. So I know 3 times 1 are my only choices for 3. But for 6, I have 6 times 1 and 2 times 3. I know that in order to multiply to get a positive and add to get a negative, my numbers both have to be negative. But I like to kind of do the signs last. Alright, so let's just start. 3x times 1x, I know that has to be right. Now this is where my job comes in, to help you make good choices. Usually I start with the smaller numbers. And here's another huge hint. You can never put in a number into the parenthesis that has a common factor. Meaning I could not put a 3 with a 3 because they have a common factor of 3. So I know if 2 and 3 works, the 3 has to go here and the 2 has to go there. So let's see if I can get an 11 in the middle. That's 2x, that's 9x, and if they're both negative, I get a negative 11x. And I know a negative 2 times a negative 3 is a positive 6. If that wouldn't have worked, then I would have tried the 6 and the 1, but I knew that the 6 could not go with the 3 because 3 and 6 are both divisible by 3. So I know that would not work. So it does eliminate some choices when you know that fact. Now, we don't have a prime number. because we have 2 and 2 or 4 and 1. 9, well, we either have 9 and 1 or 3 and 3. It's not a perfect square trinomial because that 9 is not positive. So we start trying some stuff. So I'm going to start out with 2x and 2x. So let's try the smaller numbers, 3 and 3. Will that work? That's 6x. That's 6x. Do those add or subtract to get 16? No, they do not. So I know that doesn't work. All right, so now I'm not going to give up with 2 and 2. I'm going to still try 2x and 2x, but now how about 9 and 1? Let's see, that's 18x. Ooh, that's 2x. Now what can I do with 18 and 2 to get positive 16? Well, the 18 would have to be positive and the 2 would have to be negative. Means this would have to be plus, that would have to be minus. Let's just check it out. 2 times 2 is 4x squared. That's negative 2. That's positive 18. That gives me a positive 16x. And positive 9 times negative 1 is negative 9. So that worked. If it didn't, I would have said, okay, I'm done with the 2 and the 2, and then I would have tried the 4 and the 1 and see if those matched up. What happens if none of them work? Then it would be prime. Let's look at this one. Well, thank goodness we only have one choice for 2. But 15, we have 3 and 5 or 15 and 1. So again, since my middle number is kind of small, I'm going to stick with the small choices first. Sometimes that doesn't work, but that's what I'm going to try. And the 3 and the 5, well, I could put the 3 or the 5 here because they don't have anything common with the 2. Just going to have to try it. So let's see if I put the 5 here and the 3 here. That's 5x. That's 6x. 5 and 6. Add or subtract to get 7? Nope. That doesn't work. Alright, so I'm just going to say, let's try again. Okay, so we still have 2 and 1. I'm not going to rearrange that, but I'm not going to give up on the 3 and 5 yet. Let's put the 3 here and the 5 there. Does that work? That's 3x. That's 10x. I need a positive 7. So if the 10 is positive and the 3 is negative, that would be positive 7x. So that means that needs to be minus, that needs to be plus. Again, check your signs. If I multiply those together, do I get negative 15? Yes, I do. So it really does help if you know your multiplication facts and can add and subtract negatives fairly quickly. Now number 5, do you remember from a lesson, when we talked about if you had a negative in front? We could keep it, but it'd be a lot easier if you factored it out. I don't see any other GCF, so I'm going to take out a negative 1, and remember how that changes all the signs. I'm telling you that's just going to make it a little bit easier. Now I'm just going to look at that part, and again 4 is either 2 and 2 or 4 and 1. 15 is either 3 and 5 or 15 and 1, and I need a 17. Maybe this time I might try the bigger number. I don't know. So you want to not leave out that negative as part of your answer. So you want to try the 2 and the 2? You want to try the 3 and the 5? Stick with the smaller. So let's see, that's 6x. 2 times 5 is 10x. Will that get me 17? No. And even if I switch the 3 and the 5 because they're both 2's, that doesn't work. Alright, so I'm not going to give up on the 2 and the 2 yet. How about 15 and 1? Well, if I put 15 and 1, what's going to happen when I multiply that together? I'm going to get 30x. That's just too big, because that's only going to be 2x. That's not going to give me 17. So, I don't think I've tried every combination with the 2 and the 2. So I'm just going to erase. And on your paper you don't need to erase, you could just draw lines through it. Okay, the 2 and the 2 don't work, so now I'm going to try the 4 and the 1. I'm going to go back to 3 and 5. That's 3x. That's 20x. Ooh, I'm on to something. Can I add or subtract to get positive 17? Yes. As long as the 3 is negative, the 20 is positive. If I multiply negative 3 times a positive 5, I get negative 15. I've got my plus 17. I'm not leaving out my negative sign. So that is your final answer. Again, don't leave out that negative there. All right, number 6. Again, the good news, that's a prime number, so I only have one choice. Ooh, 7 is also a prime number, so I only have one choice. This must be an easy one. All right, so 7 and 1. Now maybe you're seeing that if you put the 7 over here, it would multiply times the 5 and you'd get 35, which is kind of big. So let's try the 7 here and the 1 there. That's going to be 7x. That's going to be 5x. Well, if I add them, I get 12. If I subtract, I get 2. I don't get 3. Well, but if I put the 7 here and the 1 there, I'm going to get 35x and 1x. Well, that also doesn't get negative 3. Have I tried everything? Yes, I have. So, this is prime. This cannot be factored any further. I know, those are not fun, but at least we didn't have that many things to try. These are going to get harder because the numbers are no longer going to be prime. So 6, we have 2 and 3 or 6 and 1. And we have those on both sides. We need all positives and we need a 13 in the middle. So I'm going to try the 2x and the 3x. And if I try it with the 2 and the 3, I cannot put the 2 there because 2 and 2 have a common factor of 2. So if this works, it has to go that way. It has to go that way. All right, so we would have 9x and 4x. Well, if those are both positive, I get 13x, which is the middle term. Pretty good. Now, let me show you something. If you would have tried the 2 and the 3, yes, that's the right answer. But let's say you would have tried the 2 and the 3 with the 6 and the 1. You couldn't put the 6 there because 2 and 6 have something in common. You couldn't put the 6 over here because the 3 and the 6 have something in common. So that combination was never going to work. So you couldn't put those together or those together. The only thing that could have worked was that matching, and then the 2 couldn't go with the 2 and the 3 couldn't go with the 3. So even though we had choices, knowing that you can't put a number in the parenthesis with a common factor really narrows those choices. Trust me.